Perfect. Okay.
Wonderful.
So last presentation of the evening.
Yes.
Evening.
Okay, so as you know, we are. That's not working.
Not working this time?
No.
Okay, that's all.
Alright, go and press the arrow key.
Yep.
Alright, so as you know, we are the MUN SailBOT team. This is actually a photo at the last year's competition, 2014. So we've been involved with SailBOT since 2011, and I think this is our 5th competition. I think so, yeah. And in the previous competitions, for the first 3, we had the Arctica, which was it was a bit of a larger ship than what we're used to using now. And last year we built this vessel, which is Trixie. We built her completely from scratch, including all the appendages and the rigging and all of the design. The electrical systems were almost the same as the Arctica, but we redesigned those a little bit as well. And then this year we completely built another vessel again. Well, not completely. The keel we built last year. We built it in the same way that Queens did, actually, very similar. The keel and the rudder here, they were both built with balsa sections, little stations, and then we carved and sanded foam section in between, wrapped it in carbon fiber. The hull was built the same way as last year as well. You see a skeleton right here of laser-cut birch stations, and then we filled in small pieces of just rigid construction foam in between, sanded that down to shape, got it all nice and fair, and then we wrapped it in fiberglass. So the construction for the hull, we used 4 layers of just regular fiberglass with the Divinity Cell foam core. We were going to go with just 4 layers of carbon, like we did with Trixie last year, but we found that that's really expensive, and we just don't need that amount of strength. So there's a picture of our hull, almost completed there. Well, our hull and our deck all fiberglass together, and that's sort of in the middle of our paint job, actually. And here's just a small rendering of our hull with the keel and the bulb. As I said, the keel is the same as the one we used last year. It's 1.5 meters deep, and it's 13 or 14 layers of carbon just wrapped around some foam. The bulb is, I believe it's approximately 12 to 13 kilograms of lead. We built that one last year too. We kind of just melted down the bulb that we had from the Arctica in previous years and casted a new one. The way that it's assembled, we took the keel. It's about 15 to 12 centimeters in core length, and it's tapered all the way down. So we just wrapped it in carbon on the top, built a sleeve, took that sleeve off, and we put it right through the hull between 2 bulkheads. That way we could just take the keel, slide it down through the deck, and it just kind of sits there. And then the bulb, you can see it kind of has a section here. It fits onto the bottom of the keel, and it just bolts on. So it's really easy to assemble, and it makes carrying it a lot easier as well. It's a 2-meter class, as you already know. And yeah, next slide. So the rigging, we went with the same type of rigging as last year. So along our deck up here, there's a continuous loop which is attached to this winch. So it runs along a few blocks and goes all the way up, and then that winch turns one way or the other, and it moves that loop. And somewhere along that loop is where the main sheet is tied on, which comes back through the blocks up here and then goes to the boom. The boom, same one we used last year actually. It's a wishbone boom. It's designed to sort of give it a better shape when it's fully loaded, so that it has a neck section here. I can't remember what section it is, but when the sail is fully loaded, it kind of rests up against the boom and gives it that shape. The rigging, when we had the Arctica several years back, we had a standard fixed mast with spreaders and a forestay and an aft stay. We got rid of all of that because we found it was very complicated to set up and maintain. Instead, we took all that away and we put a mast step in there with 2 bearings that go, so it's a keel step mast, and the whole mast can rotate freely. The idea with this is that eventually we can, in future years, we can move to a solid wing mast. Probably not, well, obviously not this year, maybe not the next year. Hopefully 1 or 2 years from now. I think it would be really cool to do that. And so that's why we have a rotating mast, which also introduced some other problems, like we had to redesign the placement of our wind sensor because you can't have your wind sensor on a rotating mast because the whole sensor would rotate. So we just have a single sail, as you can see, pretty big sail. We designed it and built it ourselves using SailCAD, and we just cut it out of tieback and just taped it together with sail tape. It was mostly a trial and error process because we didn't really know how to design sails, so we just kind of looked at some ratios of other boats with the same kind of length and beam ratios and their displacement. And we kind of just threw it together, trial and error, built a bunch of sails, and just kind of stuck battens on it to see how well it worked. And eventually it worked out pretty well. Our rudder is just controlled with another motor here, with just 2 link arms like this, like this one here. So the mast is 3 meters high, and
All right, so on to the electronics. I'm sure some of you have seen the new enclosure that we've been using in the middle here. It's probably a little bit hard to see there, but I ended up kind of using this design in my last work placement, and I found that they're great boxes. And when everything's connected together and in the boat, it's actually rated for a full 2 days immersion in up to 10 meters of water. So if our boat sinks and we have to go get the electronics out the next day, they should still be okay, providing nothing shorted out, which it most likely would. But the main brains are quite electronic, so everything's basically been redone or modified this year. One thing that we're carrying forwards is we made our own remote controller. You can see it in the top corner there. It's kind of just opened up there. So one of the big issues we had was that it was not really wired quite right, and when you opened it up, it started to stretch and stretch more and stretch more. So every now and again, the slide levers on it that we're using to control the rudders and the sails, they just give you garbage data, and you start. Like our motors have an awful lot of torque, so if we were to torque the rudder to the side, I think the whole mechanism would probably snap off the boat. It wouldn't be a very pretty situation. So that was an issue. So it was just last night, actually, I rewired the whole remote controller just because we wanted to be sure when we're doing any other RC events from here on in that we don't have any issues with that. So that's one of the most recent things that's been changed. There wasn't really a whole lot of upgrades except for the fact that we can now use a full lithium 12-volt battery pack in it instead of a small little 9-volt battery, because another issue we had before was we'd only get a few minutes of run time and then it would be out, because I mean a 9-volt battery just doesn't have a whole lot of juice, especially for and the XP actually takes quite a bit of power to transmit, and it seemed to drain it very fast. I'm pretty sure the screen we're using, it's a high contrast, like 4-line character display. That takes quite a bit of power too. So another change that I added in was we kind of switched every supply all through it, any electronics, into switch mode power supply. So there's not a regulator anywhere anymore, except for soldered underneath the board somewhere. That was a last minute fix, but almost everything's above 90% efficient now. So the new remote controller can potentially last for hours, which is really nice because you don't want to lose that control. It's just a matter of replacing a battery, but that can cause you to suddenly lose your rudder control, which is a big issue for us. So that works really well now, and another good thing about it is that you can swap batteries out without turning it off. That's another thing that kind of added to a lot of the electronics. Our boat works the same way. We have large lead-acid battery cells, but you can swap one out and put a new, fresh one in without ever turning the boat off. Just the way it works. You can only have one in, but if you had to, you can swap them out, and it just makes everything a little bit easier. I guess another big problem was that we switched recently into using the Beagle board for all of our navigation, all of our brain communications, and it's really nice because you can use your laptop, you can get right into it, and you have full access to all the NEMA strings going through. You can just see so much more than you can with an Arduino. It's a lot more powerful system to use as your brain, but there's a lot of issues with connecting everything together. So instead of trying to get the Beagle bone just on top of our platform and wiring it all together, we opted for an entirely new motherboard. Now, again, it's hard to see. It's in the, I should have brought the box. It's in here. I don't think there's actually a good, it's probably software yet, there's not really a good picture of the board. But basically what's on there is there's a Beagle board that's powered. There's an Arduino Mega 2560, and that handles pretty much all of our controls of the motors and kind of handles all the system implementation. Now, the motors themselves are actually controlled, like we mentioned, the same way, just using an Arduino Mini, because you don't want to do quadrature with your main Arduino platform, because it eats up all your processing power. So you want a tiny little board just dedicated to doing the quadrature encoding. Because we're not using really nice, easy, say, PWM motors, we built our own winches, and they have quadrature encoders on them. But the encoders are on the shaft, so they give you pulses quite fast. And that's an issue when you're doing the encoding. So that's all been switched up. And we also use 15 amp Lulu motor drivers for each channel. So we could potentially move to much bigger motors. And we have no issues with the electronics are never going to short out in terms of drawing too much motor on a, like if the motor suddenly goes into a case where it's not moving and it's just at full load. We've had cases before where 5, maybe 7 amps is not really unheard of going into each motor. So they're fused now. So instead of blowing your electronics, you have to replace a fuse. It's a lot easier when you have problems. But another thing is these new Swiss motors we're using now are actually quite a bit more efficient. So we've noticed that you can completely stop them, and that there's nothing really happens. Everything recovers. Our old motors would pretty much fry right away. We actually had the last competition big problems with our motors just frying. Just the main sail does take a lot of force. So there's not too much else to mention here with this, other than like the programming cable is a huge help. It just makes it so much easier when you don't have to rip your boat apart to program anything. So what I did was we have a waterproof connector just on the top of our deck on like a Tupperware hatch. It seems to be like in the Tupperwares, it's actually really useful just to use epoxy them right into your deck. It makes a great hatch. It's a lot easier than trying to design a waterproof hatch from scratch. So we put the waterproof connector in the hatch, and then all we have to do is I made a little connector that plugs in, and there's a USB cable for the BeagleBone and one for the Arduino. And that worked pretty good, though it took me about 5 times to make the cable, because getting full speed USB 2.0 is not easy. You can't, even small segments of non-twisted, non-shielded wire will cause it to drop packets. And I cut our cable into only go this long, and it still wouldn't work. You have to only use USB cable, and we didn't really realize that. I was just using whatever was around for the cabling, and you can't really do that with the high-speed stuff. So we figured that out after, and the new cable actually works really well. So that's about most of what I have for the electronics. We don't really have a whole lot to show you here in terms of it'd be kind of nice to bring some of them, because they're really easy to pop in and out of the boat. I mean, there's only maybe 4 or 5 connections you have to make entirely for the whole system to come out of the boat and come back in. So it makes setting up our boat much easier. I mean, like Adam was saying, like with the keel, I mean, it only takes us about 5 minutes to go from disassembled to assembled in the water and going. And like with the batteries too, where you can just swap one out and you're still running the same mission plan with the same debug logs, it makes testing a whole lot easier. In terms of the software, I'm not actually a programmer, and I don't think we currently have, well, technically we have a programmer, but technically we don't.
He's in class right
Yes,
now.
I'm technically in class now too, but this is my day off. So what I can tell you is that the BeagleBone, we're using C++. Just we're not doing anything too complicated with that right now. It's a pretty basic sailing algorithm, which I would imagine is very similar to what some of you are using in terms of just seeing where the wind's coming, seeing where we're trying to go, and we're obviously not going right for the GPS coordinates. I think we're just doing 1 or 2 just tacks kind of to get there. So that seems to be working okay. Our autonomous sailing, in terms of controlling the mast also worked, I think, okay yesterday. But the GPS navigation doesn't seem to be quite working yet. One of the issues there is that I only calibrated our air sensor last night at 5:30. I think we finally got it to calibrate. We had to run out on a motorboat and get it to do large kilometer circles to try to calibrate the instrument. So that worked, and we're feeling pretty good about our wind sensor readings now. It's not just reporting raw data or garbage, and we didn't have to do any parsing, and we actually get very solid wind angles. We tested that. So I'm thinking that last year there's somewhere in the code there's a ghost 180-degree switch for some sensor that was backwards, and that's causing our autonomy to fail right now. So hopefully that's a quick bug fix that can be fixed. So the idea here is that there's a simple state machine using for sailing, which is similar to, I think someone mentioned, like they have different, maybe there's 8 different points along a circle, or maybe it's 45-degree points. That's kind of the idea, is that you do it in states, but you're never really in a loop looking for something. You're either in this state, or the wind's coming here, and it's just a big state machine, and it makes it really easy to debug, because if you're in one state and then you went into a state that you shouldn't have, well, why did I do that? And it kind of simplifies everything. And the Pro Mini and the Arduino are just programmed in C, which I'm assuming means that they're just programmed using the Arduino environment, which is pretty typical for programming Arduinos. I'm sure, as you all know, there's some issues with that. Usually when you miss some of the registers, just in the libraries don't quite line up, and sometimes it can cause problems. But right now our RC control does work, so all of our internal boards, everything seems to be working right now, which is great, because we've had problems with the Arduinos just seem to wipe themselves sometimes. We haven't really found if it's maybe a reset pin that's got noise or what the problem is, but the BeagleBone's been excellent, but the Arduinos we found just sometimes they seem to lose the code. It doesn't make a whole lot of sense. So another thing is that we use our own filter for the wind. So instead of trying to do a continuous algorithm where you say I'm going here and you're trying to calibrate your wind readings, we actually use an 8-quadrant filter, which means that depending on which quadrant you're in, there's a different algorithm for the filter. So it's kind of like a way to linearize it without trying to write a complicated algorithm. I don't know if that makes sense to everyone here or not. It's not just a linear revolution, like you said. It can skew a bit, but if you do a calibration and you just split it into 8 quadrants, then the calibration itself is not that complicated, and it's a good way to kind of smooth it out a bit. And there's debug logs that work really well right now. We're actually going through one, our programmer's looking through one right now, trying to figure out what went wrong yesterday with our autonomy, because when we started out, we just beeline for the shore, and that didn't make a whole lot of sense. So I'm assuming there's going to be a 180-degree offset there, and the problem solved. But having a good debug log or something like that is very important when you're trying to get through this. Other than that, for the software, there's not a whole lot of detail I can go into, because I've never even so much as seen the code. But I know the hardware, so I have a good idea about how everything's working together.
We'd also like to just kind of say what we would do differently next year based on what we learned this year. Because that was our main design mission from what happened last year. So for the hull, for example, we saw last year we had a very poor hull. Basically, if she's going downwind from the mast forward, she was a submarine. And she would just completely dive. So we also noticed that she was pitching very violently in waves. So those were 2 issues that we tried to fix with the whole design this year, which we did. It worked out great, actually. So next year, one of the biggest things is I want to try and make a new rudder. The rudder that we have is a NACA 10 section, which was I was hoping we could use it for smaller angles of attack, because it produces less drag, but it stalls out at larger angles of attack between 5 to 10 degrees, but our motors just can't be that precise. So I'd like to build maybe a NACA 12 section, which is just a little bit thicker. It'll give you a little bit more drag, but it won't stall out as much. So that's one change I'd like to make, and maybe, well, we are going to have to replace the hatch next year, because the Tupperware hatch, I had trouble bonding it into the deck. It was so smooth, I had to sand it and try to epoxy it multiple times, and I broke it out a couple times. So they have like a longer hatch, bigger hatch, which would be harder to seal, but it'd be nice because we could